Greetings to all of you. I am Dr. J.R. Mudkavi from the Department of Chemical Engineering, Indian Institute of Science, Bangalore 560012. In this course, that is inductively coupled plasma atomic emission spectrometry. In short, it is ICP-AES for pollution monitoring. I would like to introduce you to one of the most modern elemental analysis technique, which is basically an extension of a series of optical spectroscopic techniques developed since 1930s. The first among them was spectrophotometry, followed by fluorescence spectrophotometry, and then down came in around 1955 the atomic absorption spectrometry. Now it is the era of inductively coupled plasma atomic emission spectrometry. Usually it is also known as ICP-OES, optical emission spectrometry. So, the techniques described above, they were all developed in the 1960s, but the analytical potential of the technique was realized by the early work of scientists such as Greenfield, Professor Wendt and Professor Fassel. The application and development of the ideas have now become the basis of quantitative ICP and AES analysis. That is, it has become part and parcel of our chemical analysis technique, which will be very useful for scientists, students and the practitioners of the analytical science also, along with several other techniques, several other fields such as geoscience, environmental engineering, water analysis, metal analysis and myriad applications. So, most of people involved in the analysis of metal ions directly or indirectly are aware of the recent rapid development of ICP-AES. We are all amazed actually how fast the technique has caught on with very beautiful, delightfully straightforward technique, ease of operation and automation to comparable to atomic absorption spectrometry, but it is much more than that. It allows you multi-element determination simultaneously, even though it is a destructive technique. So, the technique has got the attention of all scientists all over the world, so much so that it has become part and parcel of our graduate studies syllabus, postgraduate studies syllabus, and then all over the world universities are teaching this technique. At the same time, any established laboratory engaged in the analysis of metal ions must have atomic absorption this ICP-AES as an essential equipment in most of the modern analytical laboratories all over the world. So, the applications of ICP-AES, as I told you earlier, they include environmental sciences, geosciences, water analysis, metal ions in a myriad applications and samples at parts per million, parts per billion and parts per trillion PPT, that is 10 raised to minus 12 grams analysis. In this respect, it surpasses the atomic absorption spectrometry and definitely that of spectrophotometry, and sometimes it is even much better than atomic absorption spectrometry in terms of sample throughput and ease of operation. That means, you can do number of samples in a very short time and then finish the total analysis as such within no time. So, this course is an introduction to the spectrophotometry of ICP-AES for those who use it as a routine analytical application for ICP-AES. An explosive growth of literature in the applications of this ICP-AES technique is ample proof of the popularity of the technique and its further potential, future potential also supposed to be enormous. So, I wish all of you will study this course, try to understand the techniques, fundamental principles, applications, etc. This course provides a detailed account of the ICP, that is inductive coupled plasma technique, its theoretical principles I will be teaching you. I will be teaching you about the instrumentation and sample handling, multiple element applications and environmental sample analysis, water analysis, etc. It is intended for BSc graduates, it is intended for MSc graduates, postgraduate, postdoctoral students, and it is also intended for engineers in environmental science, chemical engineering, metallurgical engineering and geological engineering. Also important for biotechnology students. So, it is designed on 2 courses which I have offered earlier on spectrophotometry and atomic absorption spectrometry. If you wish, you can go through those 2 courses, and I have divided it into 4 modules. The first module is the introduction and the second module covers the principles of optics and basic electronics and automation, computer, etc. fundamentally required in any instrument. You must have the knowledge of prisms, gratings and many other things which we continuously use in most of the instruments. If you have taken my earlier course on spectrophotometry or atomic absorption, probably this will be some sort of revision for you. I will try to keep that minimum, and if you wish you can go through those courses, fundamental principles of instrumentation and optics. But otherwise what I will be teaching you in the third module, that is apart from instrumentation, analytical aspects of chemical element analysis followed by the applications. So, we will be covering most of these principles as a technique of ICP-AES, and I wish you good learning. Thank you very much.